Okay, at the top of your notes, you can see this is already written for you. Just talking about what we're going to talk about today. We're going to talk about different graphs that you can use if you have categorical or if you have quantitative data. Some can be used for both, but many of them cannot, so you have to be careful about that. Google Sheets is coming up, but actually I've changed the order of your lessons. So today's activity, we're going to draw a histogram by hand, but we are going to do Google Sheets next class or the class after, and that's how you're going to be doing your graphs for your project. Okay, moving on. Let's see. Okay, so on your paper it says counts, and you're going to want to know what counts are. Counts are actual numbers, and it says they're not always reflective of the results. So for example, if I have in this bag 20 pink frogs, but I hand them out, then perhaps I'm not going to be handing out 20 pink frogs. So the counts are actual numbers counting something.
You already knew what I needed.
Yep. All right, rates. Rates are percents or proportion, and it's easier to see results that way. So instead of me telling you that I have 20 pink frogs, it would be easier if I told you that 30% of the frogs are pink. That's a more meaningful number. Did anybody coming in late bring a pass with them? Okay. All right, bar graph. So a bar graph is usually used for qualitative data, and then the count would be on the y-axis. So if I had you graph the number of each color of frog, the color of the frog is qualitative. You always need to have a title on your graph. So on your quiz, if I ask you to draw a graph, it may or may not say, remember the title, and you just need to do that. The count or the frequency is on the y-axis, and you do actually have to put the numbers there. You can't just say, okay, they're going to know that's 1, 2, 3, 4. And then the categories will go on the x-axis. Pie chart. Okay, the pie chart is usually qualitative. Sorry, it says qualitative. Oh yes, that's what type of data we have. The most important thing there is that you use that to represent parts of a whole. So if I have a whole number of 60 frogs, and I want to tell you that 25% of them are pink, I could use a pie chart. If I wanted to do like in your project, and I wanted to tell you how many calories there are in a chicken salad from different restaurants, there is no whole to that data. So that would not be a good use of a pie chart. There's no way to analyze a pie chart with socks. That makes no sense. You can't say that that pie chart has a left skew or a right skew. You can't talk about the center of that pie chart. So if you see a pie chart, please do not try to analyze that with socks. A pie chart would still have a title, and it's going to have a little key for the parts to it. I think the key got cut off in that picture, but you would usually have a key. Dot plot. Dot plot is usually quantitative data. You're going to use a count, and you're going to use one set of data. Notice that there are numbers on the x-axis. So instead of the colors of the frog, there are numbers on the x-axis.
No, I don't.
Okay, moving on. On the other side, stem plot. So you may have done a stem plot starting in middle school. It is usually quantitative data, similar to a dot plot. The stem is, it says all but the final digit. Yes, that's true. And then the leaf is the final digit. Some people who haven't seen these before find them very confusing to look at. It's very important that you have a key to help people make sense of it. And you're going to have a title, of course. Okay, pictogram. Pictograms are fun to look at, but they can be very misleading. Oh, you're frozen. My bad. They can be very misleading. The reason why a pictogram can be misleading is because the pictures don't only have a length, they also have a height. So something that is twice as long might also be twice as high, resulting in a graph that looks 4 times as big. So, like, let me show you a different pictogram. Number of baseballs. And how many baseballs do we have at South Lakes? How many do they have at Oakton? How many do they have at Madison? Well, say they have twice as many baseballs at South Lakes as they have at Oakton. And Oakton has twice as many as Madison. You can see that this circle is twice as high as the Oakton circle. But, go ahead, say it.
But it also has more area.
It has more area, right. So it really looks like we have 4 times as many as Oakton has. So pictograms you have to be very careful with. Sometimes people will try to mislead you with a pictogram. Go ahead. Let's just wait till we finish these and then do it first. Okay. After the expectations for all graphs, we are going to do a histogram, and then we'll be done after that. Oh, I'm so glad you're here. Thank you. All right, expectations for all graphs. You need to label with a title. You need to label the x-axis and the y-axis. You need an appropriate scale, but it has to be consistent. You can't mark your first number at 5 and then your next number at 50. Okay, if you're going to go up by 5, everything goes up by 5. On your project, you're going to use software. It says Minitab or equivalent. The equivalent is Google Sheets. That's what we're going to start out with. And analysis with SOX when appropriate. And without that, we'll find new ways to analyze graphs. All right, on the bottom, we're going to make a histogram for these quiz grades. So write down what the data are. You have 72, 85, 90, 93, 81, and 88. For a histogram, you need to decide what your bins are going to be. Those are how far apart you're going to put your marks on the x-axis. I decided to go by 10s because you've got C's, and then you've got B's, and then you've got A's. I put a title, grades on quiz, and at the bottom, what are these representing? Those are the actual scores or the grades, so you can just write grades for the x-axis. And then on the y-axis, this is called our count. And we're going to need a few here. 1, 2, I think 3 is all we need. So 1, 2, 3. I think I can give you some graph paper for your histogram for the gummy bears. Not the gummy bears, these frogs. But for now, sorry that this is a little messy. Okay. So we have 70 to 80. How many grades from 70 to 80? How many? Just one. Yeah, 72. So you draw like a little bar. In a histogram, the bars are connected. There's no space between them. How many grades from 80 to 90?
3.
Okay, I heard a 3. Was anybody confused by that question? Because 90 is right on the line there, right? So if a number is right on the line, you put it in the higher section. Okay, so the 90 is going to go into the higher section there. So from 80 to 90, we have 3 grades. So we're going to go up to 3. And then from 90 to 100, we have how many? 2. Yep. Okay. So when we do a histogram for your frogs, you will have more than 3 bins. 3 is actually not really a great number. I should have split that into like going by 5, 70, 75, 80. But I just wanted to give you a little example of it before we go into activity. All right.